In this module, we shall discuss, draw and describe another type group of lithic tools which belong to the Mesolithic culture. Such type groups are commonly known as microliths, which dominate the Mesolithic culture of Europe, late Stone Age of India and Middle Stone Age of Africa. As the name signifies, microlith means a very small, fine and pressure flat flints or fluted plates made on flints. Conventionally, only those small, tiny stones are called microliths. They are deliberately shaped into tools by secondary working or retouching. As a consequence, this term is strictly applicable to narrow and small flakes. There are various types and varieties of microliths. These types and varieties are determined according to deliberate shape given to them by early men, while shaping them further by trimming the edges by retouch. Most of the important and recurrent types of microliths are core, blades, geometric and non-geometric microliths. I would like to describe something about the microliths. Microliths are the very tiny tools. They are drawn like bone tools. That means drawing only the dorsal surface, not profile and not ventral. So we should draw first about this dorsal surface and then finally to the cross section like the bone tools. And the techniques of drawing remain the same as that of the flake and core tools already drawn in the previous classes. For an accurate drawing of a given specimen, each student should follow certain procedures which are similar to earlier lithic tool drawings. Here, in the Mesolithic culture, all the tools are very small and they are represented by the illustrations of the dorsal surface and cross section of each tool. Thus, it is similar in one sense with the accurate drawing of bone tools. The usual procedures are: number 1, orientation; number 2, nature of presentation; number 3, required instruments and materials; and lastly, number 4, technique of drawings. Most of the tools should be placed facing their working ends either facing left or right lateral sides, except crescent variety and the fluted core. Like the bone tools, particularly harpoons, each tool is required to draw its dorsal surface only. Then it is followed by illustration of their respective cross section just below their corresponding images. No profile or vertical views are drawn. Next come to the nature of presentation. Each three-dimensional given microlith is represented by two-dimensional image. The boundary of the tiny tools are drawn by using conventional thick lines. The edges are also represented by the same thick lines, whereas the shape, size and nature of the flex curves, either primary or secondary, either deep or shallow, etc., are done by using somewhat curved and more curved lines. Straight parallel lines is used for filling the space for both cross-section drawings. Now come to the required instruments and materials. All the instruments and materials to be supplied by the department concerned and needed materials to be brought by each student are similar to other previous practical classes. Now come to the technique of drawing. Like other lithic tools, we should measure the length of the given specimen. It measures 2.6 along its axis. Then we should draw a straight line forming its lower boundary or proximal end. It forms lower boundary or proximal end. So, while drawing the microliths, we used to draw different types of microliths, Ritter's type and simple plate along with the fluted core. This is the fluted core. These tiny blades or microblades have been removed by using fluting technique. One important point is that in case of these microliths, we always use only one line forming the lower boundary or the proximal boundary of the given specimen. We never use the distal boundary because we used to draw various types of microliths and fluted cores having different heights. So, we never use the distal end or distal point or the upper boundary of the tool. Before drawing this given specimen accurately, like other lithic tools, whether it may be core tool or flat tool, we used to dissect this specimen into two parts by drawing an imaginary line, and one of the halves should place parallel to this working table. If we get similar height out of the 4, if we got 3 having similar height, then we consider it is placed properly. Then fit the remaining portion by using model clay. It can be transferred in the same way and fix it here. Then drawing should be started. Then we can remove this and keep it properly. Then we can join these lines. Then we can measure the ridges. So it starts measuring from here up to here and up to here. Thus we can join these things again. It starts from here and goes up to this and it goes to this. We have already completed the accurate drawing of the microliths. Now let us describe these tools systematically. Before describing a tool systematically, we should note down the museum number or accession number written on the specimen. It indicates the place where from it is collected or explored or excavated, or even the place where it is housed or exhibited. The next point is we should mention the raw material for shaping this tool. The given specimen is made from chalcedony. About the state of preservation, the given specimen is slightly rolled and slightly patinated. Then let's come to its measurement. The maximum length along its axis is 3.1. Maximum breadth along its half length is 0.9, and maximum thickness along its half length is 0.5. Next, let us describe about the state of preservation. The given specimen is slightly rolled and slightly patinated. The given specimen is a tiny flat tool. It is somewhat rectangular in shape. Then let's come about its dorsal view. The dorsal surface is represented by two parallel flexures. These two parallel flexures, and it forms and arises towards its middle part. And there is also another smaller flexure present here. And towards the lateral side, there is a number of secondary flexures or retouching. The length of the tool exceeds twice its breadth. Now let's come to the profile view. The line of profile is continuous and somewhat straight. We can see a number of retouching near the line of profile. Then let's come to the ventral view. The ventral surface is represented by a single flexure. Now let's come to the cross section. The cross section is somewhat triangular in shape, like this. Now let's come to the probable tool making technique. From the shape, size, and nature of the flexures present on the specimen, the given specimen might have been prepared by using fluting technique or punching technique or indirect percussion. From the shape, size, and nature of the manufacturing technique, the given specimen is identified as microblade, having retouching work, and simply known as retouch microblade. Now let's come to the probable cultural period and chronology. Culturally, this given specimen belongs to Mesolithic period and chronologically belongs to Holocene times. Now let's come to the probable function and economy. The given specimen might have been used for cutting purposes after hafting to a handle, or it might have been used as the barbs of harpoons after embedding to the main stems of the barb. Economically, the given specimen might have belonged to hunting small games, fishing, and gathering economy. Unlike other heavy tools, drawing and description today, we have discussed on the different type of microleads, particularly how they were manufactured and implemented. Then they were drawn accurately following the necessary procedures and describe them, each tool or specimen systematically. Thus, we can conclude that these microleads are used as composite tools after hafting to a handle or fixing to a main body during Mesolithic culture of Holocene time in hunting and fishing economy. Thank you all for patient hearing.